So, we are looking more at circles, and in particular here, we're thinking about some more on the angles of circles. Now, we had said before, back when we had first talked about inscribed angles, an angle inscribed on our circle is always going to be half the measure of that arc that it opens up into. Well, this is very similar to that. Well, first of all, we got some more vocabulary. A segment or arc is said to subtend an angle. So that arc EF that I marked X subtends this angle because it is formed by the endpoints. So that blue segment subtends the angle. So does this arc. It subtends the angle. Anyway, some more terminology for us. But as we look down here at our new situation, it's not that crazy new to us. We're looking at an angle, once again, that's opening up into an arc. But this angle is formed by a tangent to a chord. Okay, look at that angle right there. Well, once again, that angle is opening up into an arc. And because that angle has a vertex on the circle, think of it the same way as we did with the inscribed angles. It is going to be half the arc that it opens up into. It's still really the same thing. And though it looks like a fairly different situation, the arc that it opens up into has an endpoint on that circle. So once again, that inscribed angle is half of the arc that subtends it. So here, we want to find the measure of ABC. We want to find the measure of that angle right there. That is essentially an inscribed angle. It's formed by a chord and a tangent, but the vertex is on the circle. So we know it's going to be half of the arc that it opens up into, half the arc that subtends it. So that angle is 94 degrees. Over here, the situation, it looks like it's hard to kind of see what's going on. So I'm going to draw it much bigger. Look at this. Same situation. We've got a line that is tangent. There it is. There's our tangent point. There's our PR. Here's S out here. And we're told that this angle is 30 degrees. We want to know PR. What is the measure of this arc right there? Well, that is the arc that subtends this angle. That angle is going to be half of the arc. That arc would have to be 60 degrees. Now this is what we're really after here. What if we have an angle somewhere inside of our circle? So this is not inscribed. The angle is not on the circle. It's not in the center either. It's not a central angle like we've seen before. Central angles had the same measure. If this was 40 degrees, this angle would be 40 degrees. It's not that. This angle is not central. Well, what we need to remember is at an intersection, vertical angles are congruent. Those two angles are congruent. Right here, these two angles are congruent. If we look at the red, those red angles, their measure is going to be the average of their subtended arcs. Is the average of the measure of the arcs they open up into. Same thing for the blue ones. It's the average of the arcs that it opens up into. We want to find X. X is going to be the same measure as that angle over here. Those angles open up into 70 degree arc and 195 degree arc. So I know the measure of X is going to be the average of 70 and 195 degrees. Add them up, divide by 2. We get 132.5 degrees would be our value for x. Finally here, angle 1 would have the same measure as this angle down here. And so we can see that it opens up into this 86-degree arc, it opens up in this 50-degree arc. It is going to be the average of 50 and 86 degrees. Add them up, divide by 2. 68 degrees. Angle 1 would have to be 68 degrees. Both of those would be the same measure.